So hi everyone, thanks for joining and welcome to the first session of the new 102 working stream at this year's annual event. My name's Chris and I'll be co-chairing with David Lee. So just a little bit about the stream first. It was created to follow on from the existing 101 working group for the purpose of providing kind of a more in-depth look into all things IBM Z related, focusing on specialised areas and going into a bit more detail on topics that may have been introduced within the 101 stream. It's ideal for anyone with a couple or more years experience on the platform, or for anyone interested in starting to learn a bit more about other areas that they may not have had much exposure to. So this session in particular is an introduction to SA systems automation being delivered by Dave Swift. If you do have any questions throughout, please feel free to use the chat window and I can pick these up for Dave at the end of the presentation. So Dave, if you could please introduce yourself and just kick off the session when you're ready.
Okay, I'm Dave Swift. I currently work for Nationwide Building Society with Chris. I specialise in monitoring and automation. Prior to that, I worked for IBM for nearly 30 years, again specialising in the monitoring and automation products that IBM produce. Right, let's get going. I've probably got too many slides, so we'd better crack on. So what are we going to cover? We're going to cover the IBM product currently called IBM Z System Automation, which I'm going to shorten to SA for the rest of the presentation. I'm not assuming any prior product knowledge, but because it's a 102 stream, I'm going to assume basic knowledge of the Z environment and ZOS in particular. The material I got from IBM sources, so I've put copyright IBM on most of the slides, so you need to think about that before you reuse the slides. And I suggest you ask any questions in the chat at any time. I don't want you stewing in your juice, not understanding things for 30-40 minutes. So initially we'll cover some reasons why you might want systems automation. Primarily because it makes automation easier. If the only thing you remember from this presentation is this, it's this next line. It's a policy-based approach. That makes it pretty much, as far as I know, unique among Z automation tools. Most other automation tools by other vendors are toolkits, and there's lots of script writing. Whereas SA, you define a policy, and SA has got lots and lots of built-in capability to execute that policy. So there's a lot less need to write your own scripts, which means there's a lot less testing that needs to be done, which means a lot less maintenance needs to be done. So, and also when you do the automation, when you define the policy, you can easily reuse that. So if, for example, you've got a DB2 defined in automation, and the DBAs create another DB2 subsystem, you can easily reuse that and the existing definition you've got and just change the name. So within seconds you can define an entire new DB2, without having to code it all from scratch. So there's an example of it there. So you've got a DB2 Apple on sys1, and we cloned it to DB2 Apple sys2, as I say, in seconds. So making automation easier is about making the administrator's life easier, but also system automation makes operators' lives easier because the policy handles complex dependencies between elements. So that means operators don't have to remember what's dependent on what. The policy contains all the commands necessary to take actions on applications, like stopping and starting things. So that means the operators don't need to remember what the commands are. They don't need to remember what the command syntax is, and they can't make finger trouble because they're not actually typing commands. And if necessary, the operator can easily suspend and resume automation if something special and unusual needs to happen. So, and this is the other thing you need to remember about system automation, if it's the only thing you remember, is it's goal-based. So policy-driven and goal-based. So the combination of what's in the policy and what operators ask for sets a goal for a given application, and then system automation will take whatever actions are necessary to achieve that goal without any further operator requirement to worry about the details. And it makes admin's lives easier because of the policy-based nature of it, and also there's lots of reporting that is supplied out of the box. So you can report on the policy database, you can report on availability of applications and recovery time of applications and so on, without having to write anything yourself. It's all part of the product. SA integrates with monitoring products. Surprise, surprise, the integration with the IBM monitoring product, Megamon, is an out-of-the-box function. But there is an API that SA provides, which you can use to integrate with other people's monitoring products. But that's not totally out of the box. You have to write some code, but the capability does exist. And why do you want to integrate with monitoring tools? Because that allows you to monitor the health of the application as well. So without integration with monitoring tools, all SA knows about is whether the application is up or down. If you integrate with monitoring tools, you can also detect whether it's performing properly, whether it's healthy. So what SA can do is combine the up-down status with the health status and come up with what's called a compound status. I'll show you an example of that a bit later on. But it just expands the reach of SA to really make sure that the applications are doing what you want them to. And like most products these days, SA is under continuous development. They're always producing more sample policies, new functions like nested class support, blah 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 blah. So it's not sort of set in stone. It's still a living, breathing product that's being developed. And there are lots of nice people in Birmingham, in Germany, who do the development, who I know very well, and they're all good guys and gals. So SA provides automation within a Sysplex and across Sysplexes. There are other members of the system automation family which run on non-Z platforms, and system automation on Z can integrate with those. So you can do things like establish relationships between, say, an HTTP server running on Windows with a Java server running on AIX to a DB2 backend running on ZOS. And you can make sure they are brought up or taken down in the right order. So, you can extend the reach as far as your capability requires. There's something called, you may or may not have heard of, called GDPS, which is IBM's high availability solution. And GDPS requires SA for its function. So obviously there's tight integration with GDPS. And SA exploits the long-standing and well-tuned NetView automation infrastructure. The NetView receives the messages from ZOS and puts them through an automation table. So that's NetView function, but SA provides the automation table definitions to say what actions should be taken. So it's a combination of SA policy generating the automation table statements and NetView executing those statements. It can, if you want it to, it can generate message processing facility members as part of the build process. And again, surprise, surprise, there's tight integration with IBM's scheduling product, IWS. You can integrate it with other vendors' schedulers, but it just takes a bit more work. It's not out of the box function. Right.
Dave, before you move on, are you able to quickly just click the hide icon on where it says stop sharing? Yeah, that's it. Oh, thanks, Dave.
Pleasure. Now, there are two core components of system automation. The thing that handles application and high availability, called system operations, or for short SysOps. And the thing that talks to the Z hardware, the processor, called processor operations. And again, that's normally shortened to ProcOps. And then system automation integrates both of those things into a single whole. So SysOps automates your applications. It can automate repetitive and complex tasks. It can monitor processes and messages and alerts to make sure everything's doing what it should be doing. With processor operations, it can bring up your Z servers, shut them down, recover them, and it gives you your hardware monitoring and automation, and it's from a single point of control. there used to be a third component called IOPS. So if you Google or use whatever search engine you like, you may see references to IOPS, but that's been retired because now all the DASD is on fiber channel chats and on a SAN rather than System 390 channel attached. Its reason to exist went away. So ProcOps, as I say, that talks to the hardware, the Z hardware, and you can automate the IML and NIP to when you're bringing the systems up, and when they're running, you can monitor them for status and stuff. So at the top there, you've got your focal point. So that gives you a single point of control for all your Z servers. ProcOps easy to configure because it's done through the System Automation ISPF customization dialog. Sorry, and it's easy to use because again, you don't need to remember commands, you don't need to remember the syntax, you don't need to remember the parameters. It's all coded into the policy. So what does it look like? This is a typical ProcOps panel. So you can see just in from the left there, we've got a list of systems, and it tells you what their current status is. And you can see there's a command field here on the left, and along the top there are commands you can issue. And the sort of things you can do are initialize or shut down target systems. You can change their options, like what their IPL options are. You can look at the messages, and you can display the alerts. So, policy-based automation. So, in the policy dialog, you set the configuration, you set the goals. There's a build process you go to, and then that generates the policy. And then the policy is used by the automation engine to decide what to do. And then there are user interfaces. Service Management Unite is a GUI interface. And old farts like me generally prefer the 3270 interface, and there's two different ones of those. So whichever user interface you use, you can send requests or overrides to the automation engine, and the automation engine will send status and events back to the user interfaces. So in response to status and events and requests and overrides, the automation engine will send commands to the resources, and it will monitor what those resources are doing to decide whether it needs to take any action. Pardon me. So just to hammer the point home, SA is not script based. It uses panel driven resource modeling. That's, as I say, a unique for this product compared to other ones. You establish relationships between resources, which can be within a sysplex, within a system, or sysplex wide. You can group resources together, which is a really good thing, because it allows you to do things like manage on a business application level rather than manage on a resource level. So if you look down here in this yellow box that says bank, you can see we've got a number of resources, and these arrows are relationships between those resources. So if we wanted to close the bank down, perish the thought, all you need to do is put a stop against the bank group, and then System Automation would know about all these resources. It knows about all these relationships, and it will then take the entire thing down, but it will take it down in the correct order so that there are no problems. So that's what groups, one of the big advantages of groups is you can manipulate an entire set of resources just with a single command. And you can have groups within groups, and so on and so forth. So System Automation works on a manager agent concept. So you'll have at least one agent manager. You usually have at least one secondary manager as well for high availability. Every system will have an agent on it, and it's the agent that actually takes the actions against the resources. The manager is the brain. It's the overall point of control, but it's the agent that does the actions. So the automation manager's got the central awareness of everything that's being automated. Everything's got a unique name, so it can be individually manipulated. there are 6 states that resources can have: observed state, desired state, what the automation state is, the health state, whether it's startable, and all those things feed into the compound state. Excuse me, I'll take a drink. And any of those, if any of those states change, then that will drive automation. So events will go into the automation manager. That it will then think about the policy and inspect the policy and decide what needs to happen in response to that event. It then gives orders to the automation agent to take actions, and the automation agent will execute those actions, which will coordinate the restart and failover of anything that's got a problem. So the automation manager knows about all the resources, it knows about the dependencies between them, and it knows how they're grouped together. You will define your own customer policies for your own applications, but IBM supplies lots of pre-canned scenarios for all of its software, like WAS and IMS and KICS and IWS and DB2. So again, that cuts down the amount of work that you need to do to get going, because IBM's provided a bucket load of stuff for all the common things for you. So we've got powerful relationship support. So relationships define how one resource relates to another resource. So has parent is the most obvious and common relationship, but there are many more, in fact many more than I've listed here. This is just a fraction of the available relationships, and those relationships can have conditions attached, so like when available. So here we've got to make available is a relationship, and then when available is the condition. So what that's telling you is that the KICS resource will be started when VTAM is available. So VTAM makes KICS available when it is available. Conversely, if VTAM breaks, then a force down relationship will take KICS down, because there's no point KICS being up if VTAM's down, because nobody can log on and do anything anyway. And so, and so on and so forth. So relationships are very, very powerful, and it frees the operator from needing to know what's dependent on what, and the order that things need to be brought up or taken down in. So they're very, very powerful, and they can take place across system boundaries. So that relationships are Sysplex wide. So groups are another powerful function. So it's a collection of multiple resources, and the overall status of the group is derived from the aggregate status of the members of the group. A group can be part of any dependency, like a group can have a parent relationship to something else, or a group could be a member of another group. A resource can be a member of multiple groups. Every group's got a unique name, so it can be manipulated system or Sysplex wide. And members of a group can be distributed across an entire Sysplex. And I've mentioned before, the whole point of this is to free the operator from knowing how the various resources interact with each other and the relationships between them. So what type of groups have we got? There are 2 basic types, system and Sysplex. Which is pretty self-explanatory, really. System groups, the resources are only on an individual system, whereas a Sysplex group could be anywhere in the Sysplex. The Sysplex group are divided into 3 subtypes. A basic Sysplex group, which means every member of the group must be up for the group itself to be considered up. There's a Sysplex move group where one and only one member of the group must be up for the application group to be considered up. And then there's a server application group where you can define a goal of at least N of the M members must be up for the application group to be considered up. So with those group types, you can pretty much come up with any scenario for what your application resources need. So with move groups, like this, a server group or a move group, what if say system one in this particular case goes away, then system automation will react to that, and based on what the goals are in the policy, it will move the application to another system. Calling it a move is a slight misnomer, because the actual application, the actual DB2 system itself is not started, not physically moved to a different box. You started a new resource on a different system. So it's called a move, but it's just making sure that an equivalent resource is available somewhere in the Sysplex. So yet again, goal-driven automation. So that's the one thing you need to remember. So the administrator defines the goals of the application, depending on what the business requirements are. The goals relate to the desired state, the availability schedule, and the preferred system you want it to run on. You define the relationships between the resources and the groups, and the relationships between groups. And you can define service periods. So you can say from between 8 and 12 and between 1 and 6, it's got to be up. Outside of those times, I don't really care whether it's up or down. So what the system automation manager will be doing is constantly looking at what's going on with the resources and doing whatever's necessary to make sure they're kept in line with the goals that has been set by the administrator. The operator can overrule the goals by using overrides on stop-start requests. So it's not completely fixed in stone. If something unusual happens and you need to have a bit of flexibility, there is some flexibility there to override the policy. So the responsibility for understanding all this stuff moves from operations to the automation administrator, which is probably the thing you want anyway. So originally, as I think I mentioned, system automation only understood whether an application was up or down. So you had an application lifecycle without health monitoring. So all you know is the application up or is it down? There are no gradients between being up or down. It's either up or down. And if you're not really monitoring the health, then you may get a failure because you're not monitoring the health. So an application that's degrading and gradually breaking, you won't detect until it's actually broken altogether. So once you've got a failure, you're losing money, and there's possible reputational damage. So the reason you want to do application lifecycle monitoring with health monitoring is to try and detect the degraded states before they become real problems. And if you detect that a system's degraded, the performance is falling off, you can take actions to improve the performance and avoid an actual outage. You could change the weights on LPAR so that it's got more resource to play with. You could bring up extra instances if it's an HTTP server, for example. There are all sorts of actions you can take to eliminate bottlenecks. But the point is, you've got to know that those problems are there. You've got to monitor the health as well as the up-down status, because we want to fix problems before we get a failure. So, with performance-driven automation, system automation will be monitoring the health, as it moves from normal to some kind of gradual problem state, and we want to intervene before it gets to the fatal state. So we can detect degraded health states, warning, minor, critical. It relieves the operator from monitoring messages and entering monitoring commands to check every now and then whether it's performing all right, because system automation will do it itself. And it's easier to use than issuing commands. It gives you a single port of control. It gives you a single action to do things. And it means we're now feeding the health state into automation decisions as well as the up-down state. So it's definitely well worth doing. So again, performance-driven automation, it can be active or passive. We're using it to determine the health state or whether thresholds have been exceeded. If you want to, having determined a health state, you can then go off and question other monitors to get additional information. You can send a notification to whatever your enterprise alert console is, or to a specified owner of the resource. You can integrate with call out tools, which may have an escalation process. So you might send a severity 4 alert for it being in health state warning, but then if it gets to health state degraded, you may want to escalate that call out to severity 2, say, or something like that. So all of these things are possible. You could react by starting, stopping, or moving resources to work around the problem, or try to cure the problem altogether by doing things like change LPAR weights or change the workload manager policy or stuff like that. So all of these things are possible once you know what the health state is. So enough about the theory. How do we actually operate with SA? So this is a typical SA 3270 screen called ING list. If you ever get to use SA, this is a screen you'll get to know and love. So we've got a list of resources down here on the left, and the type of resources. So APL is application, APG is application group. It tells you what system they're on. It tells you what their observed status is. It tells you what the goal is for it, the desired state. So then those two, the observed state and the desired state, are aggregated to give you a compound state. So this is the one you really care about. What is a compound state? So in this case, the compound state is satisfactory, even though it's actually down. And the reason it's compound state is satisfactory is because the goal for it is unavailable. So it is actually meeting its goal. Therefore, its compound state is satisfactory. And there's a command field on the left here. So we can do things like put a C for close. And because this is an application group, it will stop all the resources in that group. So that's the result of issuing that close. You can now see that the desired state for all of those things is now unavailable. You can see that the observed state they are actually down. So that means the compound state is satisfactory. So you can see, if we go back, so at least 2 resources were taken down just by the action of a single command. And if you put an E for vote, don't know why, you can see whether any votes have been issued against that process. So here we are. So the stop command we issued 2 screens ago is translated into a vote. So the operator has issued a vote to make this application group unavailable. So you can see it's a stop request to make it unavailable. These votes are persistent. So even if you're IPL, the votes will persist. They're held in a state of VSAM dataset. So they will survive an IPL or a crash of the automation manager or whatever. And there's a command called ING vote, which you can use to list all the votes that are currently in the system. Or as we've seen, you can issue E in ING list against a specific resource. Yeah, votes can be propagated along the relationship graph. So if you do a vote against a group, that vote will be propagated to all of the resources in that group. So if an operator goes to a console and tries to start a resource outside a system automation just using a console command, if there's a stop vote for it, SA will stop it again. There's a message that goes on the console that says the words to the effect of applications started outside system automation, and it will stop it again. And the reason it will stop it again is because the vote says this should be down. So system automation will make sure it's down no matter what. Resistance is futile, you will be assimilated, sort of thing. You will do what I tell you. So what's the appropriate way to start a resource if there's a vote? Kill the vote or cancel the vote. So you do a C for cancel, and the vote will be cancelled, and the system automation will bring the resource back up again. So votes are important. Right. So this is another system automation interface called the Status Display Facility, SDF for short. This is from another customer, so I've redacted the names to protect the innocent. But you can see basically there's a list of sysplexes and the systems that are in those sysplexes, and you can see that one of them's pink, whereas everything should be green. So if you position the cursor against the pink resource and press PF8 to drill down, you'll see something like this. So we've drilled down to the status of this individual system, and you can see that there are some resources are pink. So the fact that those resources are pink is what's is aggregated up and driven the status of the overall system to be pink. So again, we can put our cursor against one of those pink resources and press PF8 again and drill down even further. So now we're looking at the status of that individual resource. So you can see the reason it's pink is because of this message here. So system automation has detected that the starter task is actually there, but it hasn't issued the message that's defined in policy to say I'm up. So, you know, system automation is not 100% certain that it's in the right state. So that's why it's made it pink. So somebody needs to investigate why that message didn't come out. So again, it's a nice, easy to navigate interface, and operators tend to like it. And then finally, the more recent user interface available to you is a GUI called Service Management Unite. And no idea why they came up with that name, but it's shortened to SMU for short. One thing that is good about it is it draws nice topologies like this one here in the more or less the center of the slide. So that really helps you visualize all the relationships between things. So that is a nice feature, you know, and the sort of thing you can do with GUIs that are essentially impossible in 3270. So it comes with out-of-the-box workspaces to monitor the system health, to look at the domain and automation health. So you can, you know, explore the automation, and you can contact IBM support directly from this GUI. You can customize your own. There are lots of dashboards supplied by IBM, but you can customize your own. You know, and it's all the same information. It's just displayed in a different way. You know, trying to exploit things that are good in GUIs that are difficult in 3270. So the main advantage is the topology, but it's people who are younger than me are probably more familiar with this kind of interface and probably like it better. So there is a generational thing going on. You know, you can look at your groups, you can browse the logs, you can enter commands, you can see the responses to the commands. So you can do everything you can do in 3270. It's just a different way of presenting the data. Right. So policy-based automation. It's easier for the automation administrator, because you're just doing fill in the blanks. You're not writing rec scripts all the time. It's faster time to value because you're reusing existing stuff. IBM supplies loads of predefined automation for you to save you time. Because you're not writing code, you can't have coding errors by definition. You can create classes, and then when you define an instance, you can inherit lots of definitions from the class rather than define them over and over again. So overall, you're trying to make more efficient use of the scarce people resources. I mean, when I started years and years ago, you know, we had hordes of people to do things. You know, now people are scarce, you know, and they're expensive resources. So we want to make sure that we get the maximum bang for the buck out of the people, and policy-driven automation helps with that process. And obviously, having a policy means it's consistent and it's reliable, because people aren't just making things up as they go along in scripts or whatever. SA provides what are called plug and play automation. That's just IBM's term for the supplied automation modules that they give you. There is policy-based automation from the SA family on other platforms. There's a product called System Automation Multi-Platforms, which runs on Linux, on Z, and on Intel, and on AIX and Windows and AS400, yada yada yada. And that family of products can coordinate automation, across ZOS and the distributed platforms. So you can establish very powerful relationships and manipulate cross-platform resources as a single application. So it's flexible and powerful. So pretty much any requirement you've got can be defined as a policy and a goal. So yeah. So it's called a policy database, the PDB. And there's an ISPF dialog called the customization dialog, which you use to define and generate the policy. So you define the policy in this dialog, and you can do mass updates from a file, and you can report from that policy database using this dialog. Once you've defined all your definitions, you then have a build process, which is a bit like a compile, and then that generates an automation control file, which is what the agent uses to know what to do. So it will define the automation table. So when a specific message is issued, the agent will know what to do because it's defined in the automation control file. And the manager has some definitions as well. So it knows what to do when the agent reports something to it. It will decide, well, what needs to happen, and it would tell the agent to do something. And there's an output, a build output, like sysout. So the administrator can check that the build worked okay and nothing broke. So that's the main menu. So you can see there's all sorts of things you can define. You can define your systems, your sysplexes, your application groups, your applications, all your processors for the procops function. You can define monitor resources for checking the health of applications. You can set timers for performing regular actions like purging output from spool, for example, and so on and so forth. So, again, if you ever get to work with system automation, this menu will be your friend. So how do we define relationships, which is a powerful feature of system automation? In an application, you'll just say new has parent relationship or new make available relationship or whatever, and you define the resource that you want to. In the case of a has parent relationship, you define the resource that you want to be the parent. In this case, TCP/IP. So issuing the new has parent command there launches this panel. So it tells you this is the resource that you want to establish a relationship for. This is the relationship type that you want, and you can see there are lots of other relationship types you can have. And this is the resource that we're establishing the relationship to. And you can also set a condition on the relationship if you want. An individual resource can have multiple relationships to other resources. It's not just a one-to-one. So you define an application group by item 5 in the main menu on the policy dialog. You give it a name. You say what type of group it is. If it's a sysplex, you can then qualify that type with a nature, basic, move, or server. Resource automation name is the name that's displayed in ING list and stuff like that, whereas the name at the top is what's called an entry name, which is the name it's known by in the dialog. Now, it's good practice to keep those names the same because it just makes life simpler. but you don't have to. You can make the entry name different from the automation name. I've never done that. I've never seen a reason to, but you can if you want to. So you create a different kind of group, Sysplex Move group. You give it again. You give it a name. You define it as a Sysplex group. You're giving it a nature, and then you would go on to define preferences. So if it's a move group, you know, there will only be one and only one system that it will run on. But if it was a server group, you would then go on to define the N and M. And so we want it to be running on N systems out of the M in the group for it to be counted up. And you can define for a basic group, you can define preference values. So you can say, okay, there are 4 systems in this group, but I want to give this system a preference value of 1,000 because I normally want it to run there, and all the other systems can have a preference value of 700. So it will only go on to any one of those systems if the primary system fails. So you know, you've got lots of control over what happens and where things run and what they do. So there are, as mentioned a couple of times already, plug and play automation modules supplied by IBM. The comprehensive definitions for all of the IBM stuff, like WAS and SAP and SAP and DB2 and KICS and IMS and yada yada yada. So obviously that makes your life easier because IBM's done the hard work for you. There's out-of-the-box capability for managing your couple data sets and your coupling facilities. So all routine actions like enabling a coupling facility or draining a coupling facility can all be done with a single command. There's out-of-the-box supplied automation for common conditions like auto buffer shortage or log streams directory shortage, or recovering couple data sets, or system log failures, or auxiliary storage shortage. There's out-of-the-box monitoring for long links. It will capture IPL data for you. It will check your log streams data sets are working the way they should. And there are some commands there which operators can issue to check the availability of Sysplex resources like couple data sets and coupling facilities. Somebody had too much time on their hands and they created this slide. But this is just an example of the wide range of out-of-the-box supplied stuff to get you going. So you can see there's lots of stuff there. Right, so summary. Business these days crucially dependent on high availability of all your stuff. Downtime, you know, generally causes a storm on social media. That will then get picked up by conventional media, so you get bad headlines on the BBC News. Obviously, if your systems are down, you're not making sales, so you're losing money. And if your customers get sufficiently peed off, they might move to one of your competitors. So high availability is key, and the primary business deliverable of system automation is to maintain that high availability of all your resources. So policy-based automation, it reduces your costs because it reduces definition time, it reduces the amount of scripts you need to write, and the scripts you do need to write are reduced in complexity because you can call system automation provided functions which will do common things for you, so you don't have to code them yourself. It lowers the complexity of your operation by having the relationships and groups defined in policy, and then you can manipulate something as a single group rather than the individual components of that group. We've now, for about the last 10 years, SA's had the performance-driven automation. So as well as the up-down status, the automation is driven by the performance. And finally, system automation is IBM's strategic HA solution for Z. at least in part, because it's a key component of GDPS for HA and DR. So that's it. So please give me some feedback. I'm particularly interested in knowing whether that was pitched at the right level, because obviously being a 102 stream, it's hard to understand what the ability of the audience is. So I tried not to dumb it down too much, but I hope I haven't gone too detailed. So if you could give me some feedback on that, that would be appreciated. I forgot to put the QR code on that slide. Sorry, Chris.
That's all right. We can deal with that.
But it's there, and it's on the front as well. So there's a raffle that you can go into. So kindly consider donating to those worthy causes. Are there any questions, Chris?
Just having a look now. Oh yeah, thanks for that, David. David's put the feedback link in the chat as well. No questions so far.
Okay.
Well,
don't be shy.
So,
ask a question.
Let's have a look. Just I'll give it a couple of seconds to see if anyone's got any.
Oh yeah, absolutely, yeah.
No, just getting some great feedback, which is nice. But give it a couple more seconds.
Yeah, I thought I'd got too many slides, but it looks like it's about right, doesn't it? So that's always nice to know. Right. Yeah. Oh, hi Eileen, how you doing?
Yeah, I don't know about my picture being up there like that. I need to. Right, yeah. So yeah, we'll leave it there then. So yeah, like Dave said, everyone, if you could give some feedback, that'd be much appreciated. And yeah, thanks for joining. We've got another session tomorrow at 2 o'clock. It will be delivered by Simon Fairborn, again from Nationwide. And it will be Disk Storage 102, a local real world example with a bit of GDPS. So hope to see some of you there for that. But I think that wraps it up for today. So yeah, thanks for joining, guys.
Yeah, thanks everybody.
Take care.